Hi, I'm Margaret. This program along exercise is going to practice polymorphism and abstract classes and methods. In order to do that, we are going to create an inheritance hierarchy based on the class cutter. Italic within the context of a UML class diagram indicates abstract. That means cutter is going to be an abstract class and cut an abstract method. There are different types of cutters: pliers and pruning shears. Electric pruning shears are pruning shears and pruning shears are cutters. Pliers are also cutters, and pliers have a certain type, and that type has limited options, either side cutter, end nipper, or flush cutter. Those are the different choices. So here we see we have 5 different classes, and at this point we're going to start implementing them. Let's go to Eclipse. Here in my source folder, I'm going to add a new package, and I'm going to call my new package cutter. And inside my package cutter, I'm going to create a couple classes. One of them is called cutter, and I'm going to press finish. And at this point, we're going to add the keyword abstract to mark it as an abstract class right away. So here I'm going to add a few more classes. We're going to have another class which is called pliers. And pliers derive from cutter. Now here it says the superclass is Java-lang object, but that's not what we want. We would like to have it cutter, that's the package name, and cutter, our abstract class. And when we enter that right away, it's going to create a class pliers that extends cutter. We're going to add yet another class here. So here is another class. Just bring up the UML class diagram. We added the pliers. Now we're going to add the pliers type. Notice the plural there. Pliers type. So here we go. We started pliers type as a class, even though it is an enum. That's not a problem. We can just change the keyword right here to enum. Eclipse would provide the possibility to create the enum right away, but that works too. So at this point we need yet another class. We're going to create the pruning shears. Again, we create a new class here, and it's going to be called pruning shears. And it is going to be a class that derives from cutter. And then we have one last class. The last class is electric pruning shears. That derives from pruning shears. And we're going to derive that from pruning shears. At this point, we set up all the classes. Now we have to implement the specification from the UML class diagram. Let's start with class cutter. Class cutter has one field, which is of integer. It's the field size. So let's start with the field that is private integer size. And I could see private because of the minus here. Now here it says plus cutter with one parameter. This is the constructor. We're going to add that to increase our performance and to save ourselves some typing. We're going to use a feature from Eclipse where it generates code snippets for us. The way we can do that is like this. I go somewhere in my editor, I right click, I find the source option, and here it can generate different things for me. What I would like is a constructor based on my field. So here it says generate constructor using the field. Yes, we want to use the field size, so I can say OK, and here it is. Here is my cutter. And when I check, I also need a getter. So we're going to auto-generate that as well. So here I'm going to right-click again. I'm going to source. By the way, there's a keyboard shortcut. In my case, it is Alt-Shift-S. For you, it might be something else, but you can look it up. This time we want a getter. It says generate getters and setters. We only want the getters because it's a good practice to have immutable types unless we have a good reason to do otherwise. So getters are great for us. Here it is, my getter. I also need the abstract class cat. Eclipse cannot generate that for us. There's nothing boilerplate about it. So we just have to look at the signature, no parameter, return type string, and abstract. And we can do that. So here we go. It is public, abstract, it returns a string, and the name is cat, no arguments, and a semicolon because this is an abstract method. And we're going to add a doc comment right here. It says returns a string that describes how this object cats, and then as the return value we're going to receive a description how this object cats. If I check back with my class diagram, I see there's also a toString method that should be overwritten. So once again, I'm going to my source option and I'm going to create a toString method. Notice that the toString implementation is a bit verbose. It gives us the name of the class cutter, rectangular brackets, and then inside the fields with the individual field values. We're going to change that. I'm going to update the doc comment to show you what I would like to see instead. What I would like the toString method to return is a string of the following format. The name of the class, followed by a space, size, and then the size with the double quotes that indicates that we are measuring the size in inches. We are going to implement that in a two-step approach. We are going to start with a simpler version that is fine for now, and then we are going to revisit it later to make it more flexible. So for now, we can just say we need the name of the class, cutter is the name of the class, space, size, so no opening bracket, we have the equal sign right here, followed by the actual value of the size, but at the end we want to have a double quote, not a bracket, not a closing bracket. There's two ways we can go about it. We could use a character, double quote, or if we want to use a string, we need to use the escape sequence because the double quote is already the delimiter from a string. So at this point we have a toString method. We still have a little work to do regarding doc comments. We need one for the class and we need to improve the auto-generated doc comments from my constructor and from my getter. Just a quick reminder, when we write a doc comment for a method or constructor, we typically start with a verb phrase, third person. So it says initializes the field size. There's a period even though that is not a complete sentence. Something similar here, returns the value of the field size. So at this point we implemented cutter. When I look at my package explorer, I can see those red symbols. They indicate compile issues. Let's go to pliers right here. What I notice is the red wiggly line and the symbol on the side. When I hover the mouse right there, it tells me the type pliers must implement the inherited abstract method cutter cat. That is a good clue. So we need to implement the abstract method cat, and below that it says implicit superconstructor is undefined. For default, constructor must define an explicit constructor. So we need to define a constructor because the superclass cutter requires a field that needs to be initialized. So let's let's fix those issues. Right here I can see pliers has one field. It is of type pliers type. So we're going to do that right here. It is private. It is of type pliers type. And when I look here, I can see the name of my field is type. So here it says type. At this point I have my field. I still need my constructor and I still need to override the abstract method. We're going to use the help of Eclipse again. So here is my source and my constructor based on the field. One field, type, we want to have the type involved. Notice, omit call to the default constructor super is grayed out. We cannot omit the default constructor because it is mandatory. We have to initialize the superclass constructor because it requires an argument. So when I click OK, it is creating a constructor that has two parameters, the type, which is our new field, but also the size, which was the parameter of the superclass constructor. And then we can see the first statement in our subclass constructor is the call of the superclass constructor. So that is important, has to be the first statement in the subclass constructor, unless the superclass constructor has a parameterless constructor, then we don't have to explicitly call it, then it is implied. So here we have the pliers, we have the constructor cutter, and you can see here method cut. This is the method that needs to be overwritten. One thing I could do is I could just write down my method cut right here, but alternatively I can hover over this red wiggly line, and then Eclipse offers to help out, and I'm going to take Eclipse on this offer. So I say add unimplemented methods. I would like Eclipse to do that for me, and it gives me the correct method header, the add override annotation, it returns a default value, and it gives me the comment as a reminder we still need to come up with a good implementation. We're going to return the type of the pliers. In our case, this could be side cutters, end nippers, flush cutters, and then we say cutting, so I would say end nippers cutting, something like that. So we have the type and then cutting. Let's have a quick look at the pliers type. We have side cutter, and then we have the end nipper, and last but not least we have the flush cutter. So those are the different options we provide as pliers. I'm going back to the UML class diagram. Let's have another look. We implemented class cutter, we implemented pliers and the enum, that is the type of the field of my pliers. Now we're looking on the right hand side, we see pruning shares. Pruning shares are cutters. There are no additional fields, no attributes, only an overwritten cut method. So here are my pruning shares. Again, there's the red symbol that indicates a compile error. This time I can just roll over it and Eclipse is going to help us out. So I'm going to add the constructor. We have the parameter size of type integer to initialize the superclass. No additional fields, so we are done in regard to the constructor. Pruning shares still maintains the red wiggly line, so I roll over it again. This time Eclipse offers to add unimplemented methods, and we like that too. Just like before, we have the auto-generated method step. So here I'm going to change the null return value to pruning. And we're going to save that. Let's add again a couple doc comments. We should have doc comments for every public class members, constructors, and importantly for every class. And whenever you have a doc comment for your class, make sure to include the author as well as a description. So I'm going to save that. Back to the UML class diagram. There is one class left that we haven't done yet. It is the class Electric Pruning Shares. This time it is your turn. I want you to implement the class, and when you're done, I give you something to compare it with. You know what to do with the field and a constructor. Let's have a brief look at the methods. IsOn is really the getter. I gave it the name IsOn because it seems more intuitive than IsPower, but it returns the value of the field power. OnOff toggles the value of the field. So if the power is off, it will be turned on. If the power was on, it will be turned off. Cut is going to cut the pruning shares way, so it does exactly what the superclass always did, except the electric pruning share can only cut when the power is on. So we have to check if the power is on, it cuts the way the superclass was cutting. If the power is off, it just returns an empty string, because without power, the electric pruning share is not able to do any cutting. The Tostring method has the following form. First, we have the string from the parent class, so it should return the same string that the Tostring method from pruning shares would have returned. Then a space, and it would say power is on or power is off, depending on the value of the field power. So give yourself some time to implement the class. Pause the video. When you're done, press continue. Here is something to compare it with. We have class electric pruning shares, extends pruning shares. We have a field power of type Boolean, a constructor that initializes the field of the superclass. We have the method isOn, which is our getter. It returns the value of the field power. We have a method onOff that toggles the power, so we assign to power whatever the power was not before. We have the overridden method cut. If the power is on, it returns the string that was returned by the superclass. Otherwise, it returns an empty string. And then we have the Tostring method. It returns the string from the parent class, followed by power is, and then either on or off, depending on the value of power. So here we used a ternary operator for simplicity. At this point, we have all the 5 classes implemented. Now is a good time to start with a test client. Let's go back to package cutter, and we are going to add a new class, cutter app. This is my test client, and I'm going to include a main method. And now we are going to write some test code here. We're going to start by creating the following 6 cutting tools. Every time you create an object of a given type, we're going to assign it to a variable of the same type. That means if I create, for example, pruning shares, they should be assigned to a variable of type pruning share. Or if I create side cutter, which is a special kind of pliers, then it should be assigned to a variable of type pliers. Give yourself a moment, create those 6 variables, pause the video, and when you're done, press continue. Here is something to compare it with. I have a side cutter, end snipper, flush cutter, shares, and 2 E-shares, electronic shares. Let's see what the next step is going to be. We're going to create an array of cutters and use an array initializer to initialize it with the 6 variables we just created. We're also going to use a for each loop to loop through all the elements in the array. And then for each of those elements, we're going to do a couple of things. We're going to print the element followed by a colon. Next line, we're going to print the size. It's going to look like this. There is a label right here, and then it tells us the size value. In the next line, we are going to print whatever string was returned by the cut method. And then last but not least, we're going to have a single empty line to group the related output. Give yourself a moment, make that happen, pause the video, and when you're ready, press continue. Again, we have something to compare it with. Here is an array of cutters, so the type of each element is a cutter. Notice the S plural, that's important when we have a list or collection or array, because it can include multiple elements, so we want to indicate that in our name. The array initializer always has those curly braces and then in between comma separated the elements. My side cutter is of type pliers. I can add that to an array of cutter because pliers is a subclass from cutter, so this is a relationship. Something similar is true for example, shares. Shares has the type pruning shares. Pruning shares is a subclass of cutter, or electric pruning shares. Those are a subclass of pruning shares, which is a subclass of cutter. So this is a relationship that results in one object having multiple types. So E-shares 2 is of type electric pruning shares. E-shares 2 is of type pruning shares. E-shares 2 is also of type cutter. That's why we can use it as an element in the array cutter. For each cutter, see in my cutters, I'm doing something. I'm printing my object. I'm printing the size of the object with a little label, and we are calling the method cut. So even though the method cut is the same for each cutter, this was my abstract method, it is going to cut depending on the instance. Here we have polymorphism. How it is cut depends on what object it truly is. If it's a pruning share, it cuts like a pruning share. If it's a pliers, it cuts like pliers. Let's run the code. So here we're going to execute, we're going to peek inside, and we can see we have a cutter size 6, 11. Let's just bring that back up for comparison. We have the cutters of the appropriate sizes 6, 11, 5, etc. Now, when we cut, we would say side cutter cutting, end nipper cutting, because the pliers were including the type of pliers we were using. Also here, when the pruning share was cutting, it would just say pruning. Not so the electric pruning share, because the power is off. If the power is off, electric pruning share can't prune. So I was just returning an empty string. Nothing is happening. If the power is off, we need to turn the power on first. So let's do that. Let's turn on the power and also test other methods from the class electric pruning shares. Here are 2 changes I would like you to make to a test client. Right after creating the 6 objects, I would like you to turn E-shares 1 and E-shares 2 on. And then later, within the for each loop, after printing the size, I would like you to check whether the current element is an electric pruning share. If that is the case, print power on, otherwise print power off. Give yourself a moment, pause the video. When you're ready, press continue. Here is something to compare it with. Right after I created the 6 objects, I turned on eShares1 and eShares2. I used the on-off method that toggles the off position to the on position. And then within my for each loop, after printing the size, I checked, is my current cutter an electric pruning shear? I was using the instance of operator. If that is the case, I was printing power colon, because this is the part I always print, so I don't want to have any code duplication. I print it once, and then I have to decide, should I print on or off? That depends on my field value. I obtain my field value with the getter is on, and in order to call the getter on my cutter, which is an element of the array cutter, it has to be casted to electric pruning shears first. I can do this safely because we ensured that C, indeed, is an instance of electric pruning shears. Let's have a look at the updated output. I'm going to open up the output window. Here it is. You can see we have the cutter size 11, which was my electric cutter once. Now it says the power is on pruning. Power is on pruning. It would be interesting to check whether the toggling is working as well as we expect it to work. So I could toggle my eShares2 twice, which means I turn my eShares from off to on, but the eShares2 from off to on, back to off. So I expect eShares2 to be off again. Let's see what happens if we run it now. And you can see this time it tells me power off. No pruning is happening, but the user has some feedback about what's going on. At this point, I would like to have a second look at the method Tostring. We were overriding it twice, once in the abstract class cutter and again in electric pruning shears. When we were overriding Tostring in class cutter, we intended to include the name of the class and the size. Now here we can see it always tells me it is a cutter and then it tells me the size. But it would be nice to have something more specific. It would be nice if it could tell me pliers size 6 or pruning shears size 9. This is actually possible. We can dynamically determine the actual type of the object. Let's go back to class cutter and to the Tostring method. So at the beginning we just hard-coded cutter, but we can do better. Instead of that, we can dynamically obtain the name of the class of the object. I can do that by calling getClass on this instance. So getClass is a method from class object. It's one of the final methods. It gives me a class object, and we can access through that different information. If I would say get name, that would give me the package name and the name. If I would say get simple name, that is just the class name. Let's see how that impacts the output. We are going to run it again. And this time we have pliers size 6, pruning shears size 9, electric pruning shears size 12, power off, etc. We are calling the method getClass on this object. We are in class cutter, but at runtime it checks what is the type of this object, and depending on the type of this object, it obtains the appropriate class information. This was it for today. There's a little bit cleanup left, like removing duplicate empty lines, and please make sure that all of your public methods, the constructors and also the classes, have a doc comment. I hope this walkthrough helped you to deepen your understanding of abstract classes and methods and also about polymorphism. Have a great day.